afternoon and welcome to today's webcast, Small Communities and the CSO Control Policy, Options and Tools for Complying with the Policy, including the LTCP-EZ tool. This webcast is sponsored by EPA's Office of Wastewater Management. My name is Jim Collins with Tetra Tech, and I will be moderating today's session and presenting some of the material. Thank you for joining us. This webcast will focus on small communities and the options available to them under the CSO Control Policy for developing the 9 minimum controls and long-term control plans. The webcast will also include a brief overview of the LTCP-EZ template, which is a tool that can help communities prepare their long-term control plans and assist permitting authorities in their review of the LTCPs and CSO permits. Please note that several other previous CSO webcasts have been archived. These archived webcasts can be found online through EPA's NPDES webpage. We'll begin in a few moments. While we wait for others to join, I would like to cover a few housekeeping items. The materials in this webcast have been reviewed by EPA staff for technical accuracy. However, the views of the speakers and the speakers' organizations are their own and not necessarily reflective of those of EPA. Mention of any commercial enterprise, product, or publication does not mean that EPA endorses them. We have posted the speakers' contact information in case you'd like to contact them directly following today's webcast. There is also a list of relevant CSO resources available by pressing the Resources button on your screen. You will need Adobe Acrobat Reader to view this document. You can also access archives of the previous CSO webcasts for more information on the CSO policy and long-term control plans. For those of you new to EPA NPDES webcasts, I would like to briefly summarize some of the webcast features. First, if you have any technical difficulties, if you're in the U.S., call 1-800-833-2812 and click on the Help button and specify event 145860. If you're international, the number to call is 1-415-829-5211. And again, the event number for this webcast is ID 145860. You may also use the Ask a Question area of your screen to post any technical issues that you are experiencing, and this will be forwarded to the contractor on 24 to try to provide assistance to you. Please include your telephone number so you can be reached and they'll help you troubleshoot your problem. There will be several question and answer sessions during this webcast. To ask a question, simply type your question in the text box located in the lower left-hand corner of the screen. Then click on the Submit Question button. You don't need to wait until question and answer periods to submit the question. In fact, we encourage you to submit the questions throughout the presentation. We will try to answer as many questions as possible, but due to the number of participants, all questions may not be answered. However, again, today's speaker's contact information is provided on the screen. If you have questions following the webcast, feel free to send an email. There will also be several occasions when our presenters will ask you questions. The presenter will post questions in the slide window. Please submit your answers in that same slide window, not in the Ask a Question box. Due to a technical glitch, we will not be able to offer closed captioning on today's webcast. However, closed captioning will be available on the archived webcast. That'll be available probably within 3 or 4 weeks. At the end of the webcast, you'll be asked to complete an evaluation survey. The survey will appear in a pop-up window, so please turn off your pop-up blocker at this time. As a reminder, this webcast will be archived indefinitely so you can access it after today's live presentation. The archived webcast will be posted within several weeks on this same website. Finally, please do not forget to download a certificate of participation in today's webcast by clicking on the certificate button to print the certificate after the webcast. It will not be sent to you or mailed to you. If there are multiple people in the room with you, you can click on this link to customize the certificate and print a copy for everyone attending. We are now ready to begin today's session. Our speakers are Mohammed Bila of the US EPA and Tim Schmidt of Limnotech Incorporated. Mohammed is an environmental engineer, and his responsibilities include coordinating CSO and SSO, sanitary sewer overflow, issues. Previously, Mohammed worked with the New York State Department of Environmental Conservation as an environmental engineer and for the State of Maryland Department of the Environment as a public health engineer. Tim Schmidt is a senior environmental scientist with Limnotech, who currently serves as Limnotech's project manager for support to EPA's CSO and wet weather programs. Tim has supported EPA by reviewing long-term control plans and developing tools to make the review process easier and more consistent, including the LTCP-EZ tool, which makes it easier for small communities to write compliant LTCPs. So I think we're ready to begin. With Mohammed?
Yes. Thank you, Jim. And thank you, everybody, joining this CSO webcast. And I'll quickly go over the CSO. What is a CSO, and what does it mean, and what to do? Actually, the purpose of this webcast is to define CSO control requirements for the small communities. That means this webcast more focused for the small community to meet their requirements for the CSOs and how to control that one, because that is the challenge that actually EPA and we all as together will be facing for next few years for the small community because of the limitation of their resources and technical expertise. And also we'll be discuss development of LTCPs for small communities, common issues, LTCP-EZ template, and also the LTCP-EZ green LTCP-EZ template that right now EPA is in the process of developing to helping the small community to develop the LTCP-EZ with the green technology with that one. So the next slide is what is combined sewer system. And first I'll read the definition as it is in the book of the CSO policy. A combined sewer system is a wastewater collection system owned by a state or municipality as defined by the Section 5024 of the Clean Water Act, which conveys sanitary wastewater, domestic, commercial and industrial wastewaters, and stormwater through a single pipe system to a publicly owned treatment plant as defined in 40 CFR 403.3p. Okay, so there is a nice picture of the combined sewer system in the next slide, and the picture is showing that what does it mean by a combined sewer system. In a layman term, I'll say that when you are combining the sewer into your sewer is going through a common duct or a pipe through the treatment work, and you're combining the sewer for your stormwater and regular sanitary or industrial discharge. That is the system, it's combined sewer system. Now, what is a CSO? The next question. The CSO is any discharge prior to the POTW into the system that is a combined sewer overflow. That means within the system, you have a discharge and it is overflowing at a point before the POTW. And the next slide also that it is defined what is a CSO. CSOs are as it is a point source because the discharge is from a pipe. It needs the NPDES permit because by the Clean Water Act, any discharge from a point source into the water of USA need an NPDES permit. Second point of the CSO, CSO are not subject to secondary treatment requirements applicable to the POTWs. The way I defined before that what is CSO is like before the discharge of the POTW, that means as the flow is not going to the publicly owned treatment work, it does not require the requirements of the POTWs. Okay? Then the CSO impact, what is bad in CSO? Why we are talking about the CSO? Why we need to control the CSO? That is a big question that we have. Because there is some negative impacts of the CSO. That is a health-related, public health-related, and those things, if you see the chart, it's clearly said that pollutants are there like mostly bacteria, trash, floatables, BODs, solids, nutrients, metals, oils, and toxins. And consequences of those are directly public health-related or the environmental-related. It has a negative impact on the public health because we are using that water into the water body that is discharging the CSO for either recreation or our other natural resources like the fish, like the other things that is depending on the water. So CSO, that means, has an impact on the environment and the water. So we need to do something by the Clean Water Act to control that discharge to make sure those discharges on the human health and the environment can be minimized. Next slide will be the location of the CSO communities. You can see, it's like very interesting. Most of the CSOs are located northeast corner of the map. And there's a reason behind this one. CSO was designed, it was a default design. That means all those old cities, they have a sewer system that was designed to carry the sanitary or the domestic sewer, but somehow in a default, the stormwater was hooked up with the sanitary sewer system, and it became a combined sewer system. And after that, when we realized that the CSO is a problem for the public health, you can see all these new cities towards the west and towards the southeast, they become more conscious about not combining their sewer system. That is the main reason that there is not that many CSO on the other part of the country. Okay, overview of the CSO control, my next slide. The permittees with CSS that have CSOs are required to implement the 9 minimum control. That is the phase 1 requirement of his CSO permit. That means you need to have a technology-based control. Those are the minimum control that you can have to have some kind of control for a CSO. At the same time, within your phase 1, when you're implementing the 9 minimum control, you need to develop a long-term control plan. And that long-term control plan, actually the water quality-based controls. That means you need to meet the water quality requirements for your phase 2 when you implement the long-term control plan. And LTCP is implemented through NPDES permit programs. And now, as I mentioned before, today's webcast is more focused to the small system consideration. And within the policy, that small system actually have some certain requirements. Like within the policy, from the CSO policy says, as the description of the NPDES authority, jurisdiction with population under 75,000, that means a small community, may not need to complete each of the formal steps outlined in the CSO policy. That LTCP has 9 requirements. The policy said small community may not need to do everything, but there is a but which I try to explain later on. Now my next slide, what are the expectations of the small communities? Expectation, first of all, as I mentioned, phase 1 requirement, you must implement the 9 minimum controls, which is a technology-based control for CSO. Develop an LTCP with the following key elements. These are the elements that should be included. That is public participation, consideration of the sensitive areas, evaluation of the alternatives, the post-construction compliance monitoring program. And main thing that you need to do as a small community is the next slide. That is says coordinating with the permitting authority. That is actually the prime objective of this for the small community. The permittees are encouraged to discuss the scope of the long-term CSO control plan with the water quality standard authorities and the NPDES authority. There's a purpose because the policy clearly said at the same time, the small communities may not need to develop everything, but they need to work with the NPDES authority to make sure what are needed for their CSO control. And if NPDES authority or the permitting authority realize they need to do more than what the minimum that was asked in the policy, they should do those things. So that is Jim, I'm done with my part for the time being.
Great.
And now it is your turn. Take it over.
Thank you, Mohammed. Okay, I'm going to talk in a bit more detail about the 9 minimum controls and the acronym NMC. They are technology-based controls, and they're intended to reduce the actual overflows, the CSOs, and their effect on receiving water quality. They do not require major engineering studies or construction, and they should be able to be implemented quickly. And they were to be implemented during the Phase 1 NPDES permits, and implementation of the 9 minimum controls should be documented in the long-term control plan. So again, the key is that the 9 minimum controls should already have been implemented by virtually all CSO communities at this point. It's important to note that. So going through each of the 9, the first NMC, this control ensures that a combined sewer system and a treatment facility will function in a way to maximize the treatment of combined sewage and still comply with the NPDES permit requirements. Programs should include operational plans, regular inspections of facilities, training of personnel, and documentation and tracking of the program. The second of the NMCs, this control involves making minor modifications to the operation or configuration of the collection system to maximize its storage capacity during wet weather. In this simplified example of raising the weir on a control structure, and you can see that this ends up retaining more water in the combined sewer system as opposed to letting it overflow. The third 9 minimum control, reviewing and updating your pretreatment program can help to minimize discharges into the CSS from non-domestic sources, thereby reducing potential impacts of these pollutant sources in CSOs. And even for small communities that may not be part of the national pretreatment program, working with your industrial users in a similar fashion can be effective in reducing toxics. The fourth of the 9 minimum controls is maximizing flow to the POTW treatment plant, and that will take advantage of existing infrastructure that might be underutilized, either by ensuring more flow gets to the treatment plant to take advantage of excess treatment capacity, or by increasing the plant's capacity to handle the entire flow from the combined sewer system. This can involve evaluating the combined sewer system for bottlenecks at pump stations, within pipes, etc., and making sure that all flow that can be treated in the plant makes it there, or perhaps adjusting the capacity of individual unit processes within the treatment train itself. Next. The fifth of the 9 minimum controls is elimination of CSOs during dry weather, and the NPDES program prohibits dry weather overflows, the acronym DWO. And this 9 minimum control includes inspection of the system to identify DWOs, correction of the dry weather overflow, notification of the NPDES permitting authority when a dry weather overflow has occurred, and the submission of a report about the corrective actions taken. Next. The sixth minimum control is intended to reduce or eliminate floatables from the combined sewage through simple measures such as baffles, screens, catch basin modifications, nets, skimmers, and booms. 9 minimum control number 7 is pollution prevention, which is intended as a source control effort to reduce pollutants from entering the combined sewer system in the first place. Many of these are similar to what's done for stormwater, which makes sense. That's where a lot of the floatable materials are coming in through that vector. So these can include physical efforts like street sweeping, hazardous waste collection, recycling efforts, and also public education efforts to get the public thinking more about their potential contribution to CSO impacts. Public notification is an important step to take because the public will then be aware of the location of CSO outfalls, the occurrence of CSOs, their potential effects, and any recreational activities that might be impacted by the occurrence of a CSO. This can be done by posting permanent signs at outfalls, or posting notices when CSOs occur, or sending letters to residents summarizing CSOs and their impacts. In addition, websites have often been used in the last 10 years or so to accomplish a similar approach. One thing to note here is that public notification, which is one of the 9 minimum controls, is not to be confused with public participation, which is a required element of a long-term control plan. Although public notification regarding CSOs may get the public to participate more in CSO control planning when you do get to the long-term control plan stage. And the ninth of the 9 minimum controls is monitoring to characterize CSO impacts and evaluate the potential for CSO controls. Since this is one of the 9 minimum controls, it is typically done in the very early stages of CSO control planning. But it is often the start of a permittee's development of their plan about how they are going to characterize their combined sewer system and their receiving water later on in the long-term control plan process. One of the things currently being emphasized in the CSO control program is that the CSO control policy envisioned an integrated process where the 9 minimum controls, followed by the development of a long-term control plan, incorporation of requirements into permits, and then the evaluation of the success of the long-term control plans through post-construction compliance monitoring and other approaches they all build on the steps that were taken previously and the data that were already collected. So way back here in the 9 minimum controls portion of the program, the initial planning stages of CSO control, these steps will impact what happens later in the process because they set the baseline for what you know about your system and what you can do to control CSOs. And with that, we have our first poll question, and I wanted to let everybody know that we were able to resolve the issue and the closed captioning is on, so that if that's something you need, it's available to you, and we're sorry that it wasn't on until now. So, the first poll question, if you could respond to us, please, and that's simply, who do you represent? Are you representing a small CSO community, either a city or county or other utility? A large CSO community? Are you a state or federal government employee, or are you a consultant that is assisting a municipality? Are you a member of industry, or would you classify yourself as other? And if you go ahead and submit your answers on that, we'll continue with some questions, and then we'll get back to a response on this. So I'd like to actually...
Jim, while we get the answer back from the audience or the attendees for those questions, I just want to make it clear that means 9 minimum control is the technology-based control that Fed use in the CSO policy. The state may have their own technology-based control for the CSO controls. For example, like the New York State, their technology-based control of the CSO in the phase 1, they call it 14 minimum control. It doesn't mean that if for that phase 1 CSO control requirements, you must have only those 9 minimum control, or you may not have anything else. That means you need to show an effort in a phase 1 permit within your NPDES state program requirement, what it can be done for a CSO control technology base, what you need to do. Good example is New York. They have a 14 minimum control. Tim, you want to add something with that one?
I think, Mohammed, you've done a good job there. And I'm not sure I know about the New York situation. Are there other states that you know of that have different requirements for the 9 minimum controls?
Yes, right at this moment I cannot remember the name, but I have seen somewhere they call it like this, like within like the CMOM practice also, that we have the 6 minimum control.
Right.
So like I have seen some variants of this control. Some state has combined those controls together, or some state has expanded those control like little bit in a wider sense.
Right.
What needed to be done for technology-based CSO control, and I think we should be open on that one. And also at the same time, I have Jim, I'm going to just a little bit like go a little bit like I can see some very interesting question there. Especially the one that is said, the city of Everett, yes, whether they can use the slides for their own training. So do you want to answer those during our regular Q&A session, or do we have the time right now?
Well,
it's up to you.
We do. We have the time. We don't have very many questions.
Yeah, because that question is pretty quick to answer, because you all realize this is what we are doing for our CSO webcast. This is a part of the public document. That means this is open for everybody. And I appreciate, and I'll really welcome if somebody wants to use our presentation as a part of their own presentation, and I'm open for that. Just you can use, like, even our presentation will be archived in our CSO NPDES section of the EPA website. You can even use that one also for your own training, and it is available. You can download it anytime, and you can use it. And for like the Heather Griffin, I think, from the city of Everett, for sure, Heather, you can use our slide as for your own training purpose, and anytime.
Well, to add on to that, Heather, I think in addition, the resources sheet will provide you with links to EPA's website, which has all the EPA CSO guidance documents to date, as well as other resources that will probably be useful to you.
Right. And at the same time, so I'm just letting everybody know, besides whatever the guidance and whatever the slides we have on the NPDES website, I'm always available. If you have any question or training requirements, you can always contact me for any kind of public training or requirement or your own training. That will be available.
And Mohammed, I also wanted to point out that I think a little further on in our presentation, we have a couple examples of individual communities' websites where they have done a good job of putting CSO information on the web. And so I'm sure that everybody will be able to see some good examples and hopefully learn from those examples and use what they can when they design their own program. So there should be more information upcoming. Stay tuned.
Yeah, thanks.
Okay. And actually, Mo, if you want to take on this additional question by Heather, she talked about for the 8th 9 minimum control, which is public notification. She's wondering how quickly does the public need to be notified?
The answer to that is ASAP, because everybody need to realize actually public is paying for the cost of the CSO control, and at the same time, the situation that you have for the environmental control is give and take. You need to let the public make sure that they realize why they're doing this, and what is the benefit of doing this, like why they're spending $100 extra a year for their wastewater bill, and why they need to do it, that their children can play in the park, they can swim in the water. What is the benefit? And to show that one, I think it's always better to let the public participate in the whole CSO program as soon as possible. Let them be the part of the decision making. You train them why you are making the decision. You train them why the decision should be other way. Give them the option which you know is the better and what direction you need to go. And I think, Tim, you want to add something with that one?
Right. I think that we do have a slide later on in the presentation that addresses some of the public notification requirements, and I believe that there are a number of states that have passed specific requirements for when communities need to notify the public. I think there's been a lot of discussion of this recently, and some states do have their own requirements as to how this needs to be handled. So that's something that individual communities should check into to see if their state has specific requirements.
Yes, for sure, Jim. But but the overall conclusion is that the public need to get involved in the process as soon as possible, because it is always good for you. That means if they know everything. Jim, you want to add something, or you're shaking your head?
No, I just wanted to let everybody know, since the slide is up that talks about the response to our first poll question. To summarize, we have about 21% of the participants representing small CSO communities, about 10% large CSO communities, about 35% are state or federal employees, and then about 20% are consultants who are assisting municipalities. Looks like maybe one or two folks from industry, and then about 13% classified as other. So there you go. And now we'll have a follow-up poll question. And what we'd like to know here is how many people are participating in the webcast today from your location. In other words, is it just you at your computer or in your office, or do you have a group of people with you, whether it's 2 to 5, 6 to 10, 10 to 20, or even more than 20, which would be great. So if you can let us know that, we'd appreciate it. We can take some more questions if we have any. And I see, let's see here.
Okay, what do you have?
The question about sample publications, again, if you look at the resources list, it'll give a link to EPA's website, or the resources list itself has individual URLs that you can get, I believe, PDF versions of documents. I'm not sure if that's what you mean by sample publications, but the guidances and the other CSO program materials are available on the resources document or through the resources document. Here's a question about start by having the town or city mention at a meeting, then hold the town hall meeting just for CSO info and issues that can be posted in the local paper. I guess this is trying to be a clarification of how public notification can occur, although that actually sounds like notification for public participation.
Right, Jim, I think that this is just a recommendation as to how somebody could start their public process, and certainly discussing CSOs at a town hall meeting or something like that is certainly a way to get the public involved. Notification is associated with the actual occurrence of CSOs, and I think that was one of the things that you tried to emphasize was the difference between public participation, which is getting the public involved in deciding how CSO controls should be designed and implemented, and public notification, which is making sure that the public knows that knows when CSOs have occurred, because there is potentially a public health risk. So just a clarification on that.
Yeah, Tim is absolutely right, because public notification and public participation, two different issues. At the same time, so the major thing that you need to always remember, whatever you do, you need to keep the record, like in paper or any kind of thing, that what kind of participation, public participation actually you did as a public participation program-wise, because that is one of the requirements for your long-term control plan of the participation of the public. You need to keep the record. What was the public participation event itself? How many public participate, when it was done, for how long, what kind of discussion was done, and what was the decision made.
Right, and I think Jim's going to get to that in a little bit with some of his slides.
So we have the results of the second poll question. Thank you for that. And it looks like almost about 70% are just individuals, and 26% are in groups of 2 to 5 with just a few smaller groups, but of course they're bigger groups, actually smaller percentages of larger groups, as might be expected. So thank you for that information. And without any additional questions, I believe we'll continue. We'll be talking now about the long-term control planning process. So that language from the CSO Control Policy sets the stage for that. So long-term control plans focus on water quality-based controls. The 9 minimum controls were technology-based. The long-term control plans are water quality-based focus. The goal of which is to develop and implement a plan that will ultimately result in compliance with the Clean Water Act. As a water quality-based control, an LTCP builds on the steps that were taken previously and the data that were already collected during the 9 minimum controls and characterization of the system phase. Permittees should be should be talking to their NPDES authorities to make sure everyone is on the same page about how a long-term control plan will be developed. And this is probably particularly true for small communities that may not have been up on the program initially, or haven't really gotten into it that much. Feedback from the permitting authority is essential. So there are 9 elements to the long-term control planning process, and this discussion, the discussion that the communities should have with their permitting authorities should also include the state authority that's responsible for water quality standards, because ultimately the permittee will have to meet water quality standards. So the long-term control planning effort should include, or might include, things like waivers or even use attainability analysis and revisions to water quality standards. So it's important to get those folks at the state level involved early. The LTCP should result in proposing controls that can be expanded upon or even retrofit in a cost-effective way if additional controls are determined to be necessary to meet water quality standards. And I really want to emphasize the point that it's important for everyone to begin these discussions up front, to work together to analyze data, and don't let a permittee get too far into the planning process without finding out that what they're doing and that they're basing their decisions on what they're basing their decisions on, because you don't want to wait until the end of the process and then struggle and find out if things aren't really working right. There's going to be frustration and more expense in correcting the problems. Next. So the first element, characterization, monitoring, and modeling, the goal of this element is to develop a detailed understanding of the combined sewer system and the receiving water, and to learn how the system responds to rainfall events. I don't think we could overemphasize how important this step is, because this step provides the baseline or basis for all later decisions throughout the entire long-term control planning process. You have to know how your system works and where you are now at this point in time, so that you'll have something to compare to later on during the post-construction compliance monitoring stage.
Jim, I'm going to interrupt you a little bit at this point, because characterization of the system, monitoring, modeling, and characterization of the system is not required by the CSO policy for the small community.
Right.
So sometimes I get questioned that whether the small community need to do that. But if you read the policy, it clearly says there that population under 75,000, they may not need to do all the 9 elements of the long-term control plan.
Right.
But like if you ask me as a person, as an engineer, not an EPA who is controlling just going with the CSO policy, as an engineer more, what is your advice? I always advise it's always better for how small you are. You need to know what is going on with your CSO. You need to know who you are. Like I sometimes even give the quotation from the Socrates, the greatest philosopher of all time, the know thyself. That means you need to know yourself before you even start walking that what needed to be done and how far you need to walk. So my advice, though it is not required by the policy, is always wise to characterize your system and do some monitoring and modeling to find out who you are and what needed to be done.
Thank you.
You have something?
Yeah, Mohammed, this is something that I have found to be a problem during review of some long-term control plans, and I definitely agree with you that you need to know where you're coming from in order to decide where to go. And I'm going to address this a little later on in some of my slides. We'll go into some more detail, but I think, as you said, while this is not necessarily something that's required of small communities, that it's definitely a good idea. It doesn't have to be a huge effort, but just compiling some of the data that you have, putting it all in one place, it definitely should help you and help the permit writer understand where you're coming from and where you should be going. So I agree with you.
Tim, I think I really appreciate your effort of helping me with the reviewing this LTCP. And most of the time, I think we have that challenge just to determine what permittee wants to do when they have not characterized their system.
That's exactly right. It's sometimes trying to figure out when you're reading a long-term control plan where you are is difficult.
Thanks, Jim.
Great, thank you. Well, it just underscores if you took the message for small communities, the required steps for developing an LTCP per the policy are the public participation, the consideration of sensitive areas, the evaluation of alternatives, and then the post-construction compliance monitoring program. Well, if evaluation of alternatives are required, but you haven't characterized your system, you could have a challenge. But ultimately, that's correct. I'm going to be going through all of the elements, but only those 4 that we highlighted earlier are required.
Thanks, Jim.
You're welcome. Okay, next. The second element, and this one is one of the ones that's required, is public participation. Let's start with what the CSO Control Policy says about it, which is that when developing a long-term control plan, the permittee will employ a public participation program that actively involves the affected public in the decision-making and also to select CSO controls. Please note that the emphasis on active involvement of the public. The key is to make a genuine effort to engage the public. Note that the permittee's ability to implement the plan may be questioned if the public has not been involved. And quote, the public that we're talking about here would be the residents, ratepayers, industrial users, recreational interests, or other interest groups that are affected by CSOs in a community. There are a number of ways that you can get the public involved in the long-term control planning process, including setting up public meetings, forming advisory committees, sending out press releases on CSO issues and long-term control planning progress reports, sending out direct mailings, putting inserts in utility bills, developing newsletters, or even developing a CSO website, and whatever is the most appropriate for your community to give the public the chance to get involved. The long-term control plan is considered to be a living document, so it should be updated as more information becomes available or factors change, things like that, conditions change. Incorporating public notification into the public participation process is beneficial to the long-term control plan process, the development of the long-term control plan, because it can increase interest in the CSO long-term control plan development process itself. Next. So some of the expectations for public involvement specifically, first, did the public participation process work? Can you evaluate whether it worked? Did it get ratepayers and or other users of the receiving water involved in the long-term control planning process? Was the public briefed on the characterization of CSO impacts, control alternatives, and costs? Lastly, was the process documented? And again, this does not have to be an extensive effort. You can see In this example on this slide, this long-term control plan for Macon, Missouri, was only a few paragraphs, but that constituted documentation. Another thing to note here is that people might be confused between public participation and public notification. Again, public notification notifies the public about CSOs when they occur, such as posting signs at outfalls or having a website, things like that. Whereas the two things are different, so make sure that you're documenting your public participation process in your long-term control planning process. That's what's envisioned by this component. Next slide. In this example, the city of Monticello, Indiana, which is a small community of about 5,000 people, they did several things to include the public in their long-term control planning process. First, they formed a citizens advisory committee to work with them on developing the LTCP. Second, they conducted public meetings to inform the public on progress and to get feedback. Third, they prepared a brochure that informed the public about CSOs and water quality. And lastly, they created a simple web-based notification process about CSO occurrences. And this alerts users of affected receiving waters. Some other examples of public participation processes in the LTCP development process. And the web links are up there. You'll have a copy of the slides. So since a lot of generic material is available on websites, it may not be necessary to reinvent the wheel yourself every time. You could borrow, use what's already out there and adapt it to your own needs, borrow standard language, things like that. So, to sum up, here we have Homer, and it looks like it might be kind of difficult to get him involved in anything, let alone a long-term control plan. But the permittee must at least show an effort at doing this and make sure you document that effort. Okay, we're going to move to element 3 of the LTCP, which is consideration of sensitive areas. Sensitive area, it's important because in some situations, knowing how this fits into your situation may be very clear, such as when you have a beach or another location where you may have full body immersion for swimming at that beach. However, in other places it may be less clear. If you have whitewater where people go kayaking, it's not necessarily a full primary contact recreation, or is it? I mean, kayakers tend to flip them over sometimes and they get immersed. So there are some gray areas there that need to be worked out. It may even be less clear about what to do regarding the potential impact of CSOs on endangered or threatened species, such as the piping plovers shown in the left-hand corner, if they happen to have been spotted in your community. So here's a list of several kinds of areas that would be considered sensitive. But remember that these are just guidelines that each community should consult with their NPDES authority to define priority areas in their system or within their receiving waters. For example, in Bridgeport, West Virginia, there was a CSO outfall right next to a school playing field. So that was something that Bridgeport focused on. Might not have otherwise been a sensitive area, but to them it clearly was. So here we have primary contact recreation definition, and it provides relatively clear guidance on a use that is intended to be protected. Note that sensitive areas must be present and be impacted by a CSO. I mean, that it's a combination of having the sensitive area that is impacted by the CSO that's important. Next. So again, long-term control plans should address sensitive areas. Permittees should work to prohibit or eliminate overflows to sensitive areas and treat them where necessary to achieve water quality standards and minimize impacts. These areas should be reassessed during subsequent permit cycles to ensure that progress is being made to mitigate the CSO's into these areas. And with that, we're transitioning to Tim Schmidt.
Thanks, Jim. Now I want to talk about the LTCP requirement to evaluate CSO control alternatives. We're going to start with a little background on what this requirement is designed to achieve. We've stated before that the goal of CSO control is to meet water quality standards and designated uses in the receiving water. In order to do that, you need to evaluate alternatives for CSO control, including their costs and benefits. This evaluation may be less extensive for small communities than what might be required for larger communities. For example, if you're a small community, you may be allowed to consider less options than a large community might need to consider. There are two main approaches for developing water quality-based control approaches for CSOs. Those are the presumption approach and the demonstration approach. These approaches provide the permittees with targets for CSO control to meet the water quality requirements. And please note the emphasis on the word target. Sometimes people get confused about what the presumption and demonstration approaches are. These are methods that you use to try to achieve your water quality goals and water quality standards, but they are not in themselves the end of CSO control. If you do either one of these approaches and you don't meet water quality standards, you're not done with CSO control. We're going to get to that in a bit, but Mohammed, I don't know whether, I know this is a really important point that we want to emphasize, so did you have anything you wanted to add there?
Tim, I really appreciate that you just put me in the hole. And because, I always get this question from my CSO coordinator. What does it mean by presumption approach and demonstration approach? I always say, if you read the policy pretty clearly, there is an intent of the presumption approach. The policy was created when there was like thousands of overflows in some of the big cities and creating big public health concern of the water that people are swimming and fishing and that kind of things. So we did some kind of survey of some of the major cities that what needed to be done for at least taking those dirty water down to a certain limit that we can achieve the water quality for fishable and swimmable. And the graph it was drawn close to 4. That means at that time we presume, that means federal EPA, that means federal agency presume that from the thousands of overflow, if we can cut down the flow up to a certain limit, up to the 4, then we may be able to achieve the water quality standard that we're looking for. But if you read the policy clearly, before the presumption approach is set, the permittee needs to reasonably prove that their presumption is going to meet the water quality standard. Even within the presumption criteria that we have, no more than 4 overflow, no more than 4 means anything from 0 to 4. And not less than 85% capture means from 85 to 100% capture. And at the same time, end of the CSO policy, there is a reopener clause. Like you said, the ultimate goal of these two approaches approaches are not the water quality standard. This is the path that I can take to meet the water quality standard. By the Clean Water Act, if I do not meet the water quality standard, I need to meet that standard or do something else like to change the water quality standard, use attainability analysis, either changing the standard or the variance for a temporary relief. That is a different discussion we can have later on in some other webcast. But the difference between these two approaches are, in the presumption approach, you do most of the presumption that you will meet the water quality standard and little bit of demonstration up front that, okay, this demonstration is showing with this presumption you may meet the water quality standard. Your demonstration is at the end in the presumption approach, whether you are meeting the water quality standard. If you do not meet, you do reopen your NPDES permit, readjust your LTCP, and do it over again. In the demonstration approach, you do the most of the demonstration up front, that if you do this, you will meet the water quality standard for sure. Though at the very end, with the post-construction compliance monitoring requirement, you must show that you are meeting the water quality standard. That is the ultimate goal of the Clean Water Act. So I'm cutting it short.
Right.
Well, thank you for asking me the question.
Well, we'll go over some of of this in a little bit more detail, but I think, Mohammed, as you said, the bottom line is that while these are two approaches that CSO communities can take, the ultimate goal is meeting water quality standards. So these are ways that EPA feels that you can get there, but in the end, the ultimate goal is still that you need to meet water quality standards. So with that, let's move on, and we'll talk a little bit about the different CSO control alternatives. So we have both the presumption approach and the demonstration approach. The presumption approach is more of a performance-based approach where you implement CSO controls and you try to get some level of performance out of them. For example, we're going to go over this in a minute, but if you use criterion 1 of the presumption approach, which is to achieve no more than 4 overflows per year, then your performance would be that your CSO controls are getting you no more than 4 overflows per year. The demonstration approach is more of a watershed-based approach that's based on water quality data in the receiving water, and this is it looks more at the water quality in the watershed and evaluates the impact of the CSOs in relation to other potential pollutant sources in the receiving water. And in some cases, permittees may use a combination of the presumption and demonstration approach. For example, they may decide that they want to try to achieve no more than 4 overflows on average through their CSO controls, but then once they implement the control to try to achieve that, they may start looking at the demonstration approach to try to determine the impact of that approach on the receiving water.
Can you please clarify a little bit the combination of the approach? That means I'm presuming that I will have no more than 4 overflow, but to support that presumption of 4 overflow, I'm demonstrating that what I need to do to have that 4 overflow. Am I right?
Yes, that could be one way that you could do it.
Just to make it clear, because sometimes we are confused. What does it mean by combination of the presumption and demonstration approach together?
Right.
Thanks, Tim.
Yep. Okay. This is the definition of the presumption approach. And the presumption approach, using the presumption approach, is something that you need to address 2 separate issues if you're going to use the presumption approach. And that is that the permittee is presumed to meet water quality-based requirements of the Clean Water Act, basically meeting water quality standards, under 2 conditions. First of all, that the permitting authority thinks that this is a reasonable assumption based on the data and that the permittee has collected to characterize their system. And second of all, that this is a reasonable assumption considering any impacts that the permittee has in sensitive areas. So if you discuss using the presumption approach with your permitting authority and the permitting authority thinks that you have a reasonable chance of achieving water quality standards, meeting these 2 criteria, then the presumption approach may be appropriate for you. There are 3 separate criteria under the presumption approach. Meeting the first criteria is achieving no more than an average of 4 overflow events per year, provided that the permitting authority may allow up to 2 additional overflow events per year. So this is commonly referred to as no more than 4 overflow events. The second criterion would be the elimination or capture for treatment of no less than 85% by volume of the combined sewage that's in the CSF during precipitation events, and that's on an annual average basis. The third criterion is the elimination or removal of no less than the mass of pollutants identified as causing water quality impairment through the sewer system. And this is typically considered to be, again, 85% capture of mass.
Tim, I'll just make a little correction. No less than 85%.
No, I'm sorry. Yes, no less than 85%. Right.
Thanks.
Yep, of course. There is a minimum level of treatment prescribed under the presumption approach, and if you have discharges that meet this minimum level of treatment, then they are not going to be considered CSOs under the presumption approach. And so the minimum level of treatment required is primary clarification or a technology that provides equivalent removal of floatables and settleable solids, disposal of those solids and floatables, and then, if necessary, disinfection of the effluent so that you meet water quality standards and protect designated uses. The demonstration approach is slightly different. In order to meet the demonstration approach, the permittee has to demonstrate each of the following. First of all, that the planned control program is adequate to meet water quality standards. Second, that any remaining CSOs will not preclude attainment of water quality standards, and we'll get back to this in a second. Number 3, the planned control program will provide the maximum pollution control benefits reasonably attainable. And number 4, that the program can be expanded if it's not adequate to meet water quality standards. And basically, the demonstration approach recognizes that there may be other sources of pollution in the receiving water other than CSOs. And therefore, it has this reference to the fact that CSO discharges should not preclude attainment of water quality standards, instead of just accepting that the watershed or that the CSOs have to be reduced down to the point where the watershed does meet water quality standards, because if there's upstream sources of pollutants, then obviously that's not going to occur no matter what you do to the CSOs. And as it's noted in the second bullet there, in some cases you may need a TMDL in order to control the other sources of pollution into the receiving water in order to get that receiving water to meet water quality standards. And as I just said, the demonstration approach is particularly appropriate where attainment of water quality standards can't be achieved through CSO control alone. And in these cases, the appropriate level of CSO control has to be defined based on the water quality data that you collect for the CSO community and for the receiving water, any modeling that you might do, and other economic factors. So in this case, what you want to do is you want to evaluate the receiving water to see what impacts there are, and probably through modeling try to determine different levels of CSO control and what they might achieve in terms of impacts on the receiving water. This is typically going to require wet weather surveys to evaluate the impacts of CSO control in the receiving water. And so that is going to wrap up our discussion of evaluation of alternatives. And I want to move on and talk about post-construction compliance monitoring, which is the last required element for a long-term control plan for small communities. After you've done your alternatives analysis and implemented your plan, you need to develop a post-construction compliance monitoring plan to evaluate the success of your LTCP in controlling CSOs. And here's a description of the post-construction compliance monitoring step from the CSO Control Policy. I'm not going to read through the whole thing, but I want to highlight what's there in yellow. The post-construction compliance monitoring statement from the CSO Control Policy has two components. First, verify compliance with water quality standards and designated uses. And second, ascertain the effectiveness of CSO controls. And how are you going to do this? Well, the next part in yellow explains how you might need to do that. It might include the permittee conducting effluent and ambient monitoring and, where appropriate, other monitoring protocols such as biological assessments, whole effluent toxicity testing, or sediment sampling. Let's look at the two parts of post-construction compliance monitoring. The first step is verifying compliance with water quality standards and designated uses. And most typically this is going to require the permittee to conduct ambient monitoring in the receiving water to determine whether they are indeed meeting water quality standards. The next thing you need to do is ascertain the effectiveness of CSO controls. And this part's a little trickier. What exactly does that mean? Well, the first thing you need to know is what approach did you propose in your long-term control plan? For example, if you propose that you are going to try to achieve criterion 1 of the presumption approach, no more than 4 overflows per year on an annual average basis, then that would be what you're trying to determine here. You're going to try to see whether you have indeed achieved no more than 4 overflows on an annual average basis. If you've chosen criterion 2, you want to make sure that you have achieved no less than 85% capture by volume of the sewage in the CSS during precipitation events. So you need to determine, or you need to first state what you propose to do, and then evaluate that to see whether you've actually achieved that. And there's been a lot of interest in post-construction compliance monitoring. There are a lot of communities that are currently implementing their controls, and they're getting ready to do post-construction compliance monitoring. And so EPA is in the process of developing a guidance document on post-construction compliance monitoring. This document is going to include a discussion of post-construction compliance monitoring that comes from the CSO Control Policy, and also information on post-construction compliance monitoring from previous EPA guidance documents. It will include a discussion of developing and implementing your post-construction compliance monitoring plan. It will include example calculations. For example, how exactly do you calculate 85% or no less than 85% capture of combined sewage, volume of combined sewage in the combined sewer system? So it'll have some examples of how to do that, and then also some case studies of real communities and how they've dealt with this issue. Mohammed or Jim, did you want to say something about the guidance that's being developed?
Jim? Well, it'll also provide detailed information on the ambient monitoring background and setting up quality assurance project plans, things like that.
I just want to add, actually, this post-construction compliance monitoring guidance, I believe, is overdue, because the CSO program actually right now is going from implementation phase to the performance phase. That means what the implemented phase are complying with the policy requirement, like whether it is meeting the ultimate goal of the long-term control plan. And right now, the expectation, that means by the end of 2010, I'll be close to 82 to 85% of the community, either they have implemented the long-term control plan or CSO control plan for CSO control. And this is the time actually we need to produce this one. And this guidance actually, the way that we figure it out, will give it the answer for the post-construction compliance monitoring, what to do, how to do, when to do, what to do, that kind of things. So maybe we need to do a little bit more than this document that we are preparing right now. That is the phase 2 that I'm expecting to be done in the next couple of years after 2012, when I have all the water quality standard requirements. I do not have answer for some of those things right now. So I'm expecting that we'll be doing more on the post-construction compliance monitoring guidance and document in future. But I think this is overdue, and we need this ASAP.
Right. And this is something, I'll give a little summary of where things stand on the CSO program in a little bit. But yes, a lot of communities are in the implementation stage, and they're looking towards doing their post-construction compliance monitoring. And so this document is hopefully going to be very helpful. And with that, I think I'm going to turn it back over to Jim to take us through the next set of slides.
Thank you, Tim. Well, the other LTCP elements that we haven't covered yet are cost and performance evaluations and implementation schedule. So we're going to first talk about cost and performance evaluations. We'll assume for now that the permittee has evaluated their controls and is looking at their cost versus their performance. And then we'll discuss implementation schedules after. So cost and performance analysis involves looking at the performance of the proposed controls over a series of conditions for example, 3-month, 6-month, and 1-year storms, and evaluating the performance of those controls for a given design condition. Many communities then do what's referred to as a knee of the curve analysis to identify where they get the most bang for the buck with their controls. And I have a graphic, actually, the next slide, Adriana, will help show that. So this knee of the curve analysis, if you take a look at the cost represented on the y-axis versus the number of overflows on the x-axis, you can see that the cost starts increasing rapidly when achieving greater control, so that the knee of the curve, or the break point or sharp break point, is right around the 4 overflows per year at a cost of about $2 million on this scale. Here's a slightly different depiction of the cost versus performance scenario. Here's an example where the number of CSOs, rather than using the number of CSOs, this shows the number of river miles that are meeting water quality standards. But again, you still have that knee of curve at 90%, and in this case, $400 million. Okay. So for implementation schedules, this is element 8, and this is what the CSO Control Policy says about the schedules. It's supposed to factor in the financial capability as well as the relative importance of the adverse effects. So that could be the sensitive areas, what the designated uses are. A host of factors should be considered here. Next. A little bit more detail on determining financial capability. It's basically a 2-step process. The first phase evaluates the financial impact of the long-term control plan or implementation of the long-term control plan on a community's residents through things like median household income, unemployment rate. And then the second phase takes a look at the financial capability of the permittee through things like bond ratings and community debt. And this is where you project out over a future number of years where you'll be versus what your bills will be, what your cost to do the CSO, to implement your control plan will be. Next. So more details about determining the residential indicator. First, you need to add up all of the costs for current and planned wastewater, CSO, and stormwater operations, and then determine the share of these costs that are paid by residential users as opposed to commercial or industrial clients. Then you calculate the average cost per household. Next, you obtain the median household income for your area, and that can generally be obtained from someone in the community in the tax office or other financial group. Then divide that average cost per household by the median household income. And I'd like to point out that most of these data should be readily available, and there's some additional information on this in our resources document on the webcast, and I think we actually have a slide later on that has the couple of guidances EPA's put out on this. Okay, so most of the data for the financial indicator is also readily available, although it might be a good idea to get the financial folks from your municipality involved, because they should know where to find it fairly easily. Evaluate the permittee as strong, mid, or weak on a number of factors such as bond rating, debt, unemployment rate, and then calculate an average score. So for the financial capability matrix, I won't go into a whole lot of detail, but here you can see that this matrix of different residential indicators across the top, ranging from low to high, and also the permittee's financial capability indicator along the side from weak to strong. Depending on the permittee's scores for these two axes, you determine whether the community has a high, medium, or low burden. Communities with a high burden might be able to negotiate a phased implementation schedule for their CSO controls so that they don't have to incur all of their costs at once. Here are the references that I mentioned a minute ago, that there are two guidances EPA has out. One is guidance for financial capability assessment and schedule development. That's the 1997 document. And then EPA Region 5 out of the Chicago office in 2002 put out a detailed document for financial capability analysis for small communities in particular. So this next slide shows how implementation phasing might work. We just talked about using the financial capability analysis to implement your LTCP through a phased approach. So this example shows how a permittee might use the phased approach to meet the presumption approach of 4 overflows per year. You can see that the existing situation, there are about 36 overflows per year, and the permittee has planned in their LTCP in 3 phases. The first phase reduces CSOs to approximately 24 overflows per year. The second phase down to approximately 7 overflows per year. And then finally, in phase 3, overflows are reduced to the average of 4 per year.
Question break, actually. I was looking at the question that was submitted, and I think we need to have a clarification. What does it mean by small community and what is required to be done for the small community? Because a lot of questions are on the same area. That means, what does it mean by small community? What needed to be done? Even from some of the US EPA, I get the same kind of question. So to respond to all those questions together, actually, I'm going to read through the CSO policy itself just to give a clear idea. Then I'll try to define what does the policy say about the small community and what they need to do for the CSO control. I'm reading from the CSO policy, that is Federal Register, Volume 59. I'm sorry, number 75, 18690. The scope of the long-term CSO control plan, including the characterization, monitoring, and modeling, and evaluation of the alternatives portion of the CSO policy may be difficult for some small CSS. At the discretion of the NPDES authority, jurisdiction with population under 75,000 may not need to complete each of the formal steps outlined in Section 2C of this policy, but should be required through the permits or other enforceable mechanism to comply with the 9 minimum controls, public participation, and sensitive area portion of the policy. Okay, sorry. If you read this clearly, it says that they may not do. It doesn't mean that they should not do. That means some of the question that I have it here is like if it is a population less than 75,000, but it's a complex system. That means if the NPDES authority feel like to do more than what is suggested for the CSA small community, they can ask them to do more than what is said in the CSO policy. The policy is written that way. It is a may. That is, they may not need to do everything. But if it is required, the state NPDES authority can always ask the CSO community to do more than what is prescribed in the CSO policy. So it depends on your system and depends on the NPDES authority, and that is the reason that it is always wise before we start developing a long-term control plan, coordinate with the state NPDES and permitting authority to find out what you require to do. So it's a case-by-case analysis of the NPDES authority and the permittee itself, so what needed to be done for the small CSO community and how far they should do. So I think that will answer some of the questions that we received here. So any other question, Jim, you see that we should answer?
Yes, well, I think a few others. One of them was a question simply about what do I mean by caption, so I wanted to clarify that for people. Closed captioning was for the visually impaired or audibly impaired folks, so they could read there should be captioning available if you signed up for it, so that's all that means. Michael from had asked a question saying, like, when you say 4 overflows per year, shouldn't you emphasize a typical year as opposed to a heavy wet weather year? And who defines a typical year? And I think the answer to that one is simply yes. It's an average condition, typically a long-term average.
Right. I think the key there is, and this question gets asked a lot, is what is the appropriate time period for evaluating? Because the definition is 4 overflows on average. So it does imply an average year, but certainly, unfortunately, rain doesn't fall in an average pattern. So what you want to do is just determine with your permitting authority what term for looking at your longer-term record to see whether you comply with that requirement on average. If you do modeling, certainly you might be able to choose an average year, but again, you want to try to look at that with some real monitoring data, which is not going to reflect an average year necessarily.
Jim, it's a very interesting question I can see. And the question is, if a state has 14 non-minimum controls, and does a small community need to comply all 14 of them, or just the EPA's 90 minimum controls?
Right.
I need to give a clarification of that situation, I believe. Like I told before that most of the time, the 14 non-minimum control or 6 non-minimum control is either expansion or the compaction of EPA's 9 minimum control. It's basically, if you read through 14 non-minimum control and EPA's 9 minimum controls, those are the same thing. But the state is the NPDES authority. If the state asks you to do something and that does not cross the federal policy, you should always go with the state requirements. Because the state got the ultimate say, they are the NPDES authority that what needed to be done for a CSO control. Like in case of for the New York State, their 14 minimum controls are pretty similar to the EPA's 9 minimum controls. There's, I think it's like little expansion of the 9 minimum controls of the New York State 14 minimum controls. Those are the same thing. Tim, you want to add something, or?
I think there are a couple other questions that look like they're. The first one, there was a question about, says, do you still comply with long-term control plan requirements if your post-construction water quality monitoring results in compliance with the Clean Water Act, yet you have more than 4 overflow events or less than 85% capture? And I think the answer to that is if you are complying with the Clean Water Act, if you're meeting water quality standards and designated uses, then I think the number of overflows and the 85% capture, that isn't as important. If you're meeting water quality standards, that is the goal of the CSO Control Policy. At least that's my interpretation. Is that your, how do you think about that, Mo?
You're right, Tim. That the ultimate goal of your discharge is like I said, that you need to meet the Clean Water Act requirement. That means you're not violating the water quality requirements or the TMDL part or your load allocation. At the same time, so one thing you need to make sure that your permit was written that way.
That's true.
That means your NPDES permit actually is the ultimate shield and ultimate guide that what should be the standard of your discharge. If you do a presumption approach and your permit say that you should not have more than 4 overflow, you may have 6 overflow and meeting the water quality standard, but you need to realize that still you are in the permit violation. That means then you need to negotiate with your permitting authority to make sure that your 6 overflow is not meeting is not in violation of the water quality requirement. At the same time, it is rewritten in your permit that you are not in violation of your NPDES permit, because your permit is the actual ultimate say, and the permit should be written based on the water quality standard. It should be linked to each other.
Right.
So I hope that you need to understand that you need to work with the NPDES authority to adjust that overflow, that how many overflow you should have not to violate the water quality standard or designated use.
Right, that's a good point. And certainly this question, if you were using the demonstration approach, then this wouldn't be an issue at all. But you're right, if your permit says something different about the number of overflows, in addition to meeting water quality standards, then you still might have a problem. But
Yes.
That's a good point.
Yeah, because there's two scenarios here. One is permit violation, other is the water quality standard violation, but actually the water quality standard permits should talk to each other.
Right.
Any other interesting question, team or Jim?
I wanted to try to respond in part to some of the questions about the financial capability issue, and given the current economic conditions, how does that impact the analysis? And I think the answer to that is, based on the formulas in those guidances, it's a sort of slow or long-term effect. The current salaries or employment figures and things like that go into a long-term calculation of median household income. Similarly, the bond ratings of a community change over time, not probably dramatically, although if a community's bond rating is downgraded from one year to the next, that would then show up if you're using the formula. So hopefully that helps to respond to that. It's not an immediate thing. There's another question about what's a community do if it bases its long-term control plan on certain economic conditions this year, and then 15 or 20 years out, when it's supposed to be nearly fully implemented, conditions have changed. I don't know if you wanted to try to respond to that, or...
Actually, if you read the financial capability analysis guidance clearly, most of the element that, as you said, the indicator that we use is a long-term indicator. It's not for 1 year or 2 years. At the same time, the financial capability analysis guidance is a negotiation tool. If you're expecting within 2-3 years, there may be some change in financial capability, you need to negotiate with your permitting authority to discuss those issues. Like, for example, right now, the way the Michigan and Detroit area is going on with the closing all the auto industry, they will have some impact more, maybe within the next 2-3 years, more than what they are seeing today, because the impacts of today's economy will roll down further down. So that is an opportunity that you need to discuss with the NPDES authority. Another approach is if you feel like that your 20 years long-term control plan may create a big loophole, then you need to go to the phase approach, giving importance of your long-term control plan. Break it down in different phases, 2, 3, 4 phases. That okay, out of 20 years, in the first phase, I'll be implementing 2 years objective of my long-term control plan. Then we will readjust our phase 2 based on the achievement of the phase 1 and my financial capability and everything in the phase 2. That is another alternative we can do. But I'm just, my main thing just here to say is that financial capability guidance is a negotiation tool. It is not that there's everything there. It is a case-by-case analysis, and you need to work with your NPDES permitting authority that what is good for you.
Great. Thanks, Mo. One last question. Hopefully it'll be a quick one, and that is, in determining if a combined sewer system is in a small or large community, should you include all users of the POTW, in other words, both from the combined area and non-combined area, or should you just include the users of the combined area?
That is a tricky question. First of all, your sewer bill is from your sewer authority. Either it is a POTW or sewer district itself. And that is determined by the service area of that sewer district or the POTW. But it is really hard to distinguish between the non-combined and the combined population within a same sewer district. So, answer to that question, I do not have a direct answer to that question, but most of the time the population that we count is the service area of that particular sewer district or the POTW itself. Okay. But it can have a discussion with your sewer district or permitting authority if it is something different. But as I said, it depends the service area of the permittee, CSO permit itself. If your sewer district is a permit holder for the NPDES permit holder for the CSO, this is the whole population.
Okay. And Mohammed, wouldn't you really focus more on the complexity of the system and how complex it is versus, coming down to how many people what the population is, because certainly the key to the idea of a small community is that their system shouldn't be overly complex necessarily, and that's what's really driving the requirements. So it's a combination of complexity and the fact that they're small and they may not have the resources to do a full long-term control plan. So all that, I think, drives the process much more than, if you're 69,999 people versus 70,001 people. That's the complexity of the system is going to play more into that than any hard population number.
You're absolutely right. The population may be like 74,999 and some population 75,001. You also consider the complexity of the system itself, like how complex is the system, how complex even the environmental impact of the system itself also. Suppose that you have maybe like, I've seen some community 5,000, 6,000, but they're discharging in a sensitive area like a drinking water source. Now you have a totally different scenario. Now you cannot, by population, you're a small system, but your impact is on a bigger segment of the population. So it's a whole small system. That is the reason, actually, I was reading direct from the policy itself, that most of the things, CSO policy, the way it is very flexible. And it was written that it can be adjusted based on the requirement, based on the case-by-case analysis. Even most of the requirements in the CSO policy are flexible amount that you can adjust as per requirement of the scenario itself. So you're absolutely right. Population is one of the indicators when the policy was developed that we use that less than 75,000 is small. At the same time, how complex is the system? What needed to be done for the CSO control? What needed to be done that we are not in violation of the Clean Water Act? Those things need to be considered. At the same time, the intent of the policy was that it's not going to create a financial burden to the community itself. Even if you read the financial capability section of the policy, is very flexible. It says that the intent of the thing is that giving a relief to the community at the same time you are achieving the environmental goal. It's a balance of the act. That means what maximum within my capability I can do to achieve my maximum environmental benefit. So the whole thing is like a give and take situation. Jim, you have anything to say?
No, you've said a lot there, Mo. I think we should move on and let Tim wrap the slides up, and then we do have time for questions at the end.
Thanks, Jim.
Thank you.
Okay. Actually, we have a slide here from the city of Seaford, Delaware, that is an example of the city completing their sewer separation program in a phased approach over 18 years. This is a small CSO community, a population of a little less than 7,000 people, with a CSS area of a little less than 2 square miles. And this community implemented a sewer separation project over 18 years at a cost of $2.2 million. So you see that based on their financial capability analysis, they were able to phase in their program over a relatively long time period. However, now Seaford's efforts are directed at controlling stormwater discharge now that they've separated their sewers. So, next slide. And what I want to do now is talk a little bit about some of the common issues for small communities. This is a small community webcast, and we've touched on some of these issues before, but now we're going to go into them in a little bit more detail. And I want to talk about the characterization step, characterizing the combined sewer system and the receiving water. Also choosing your CSO control approach. And lastly, I want to talk a little bit about sewer separation. So first, characterizing your system. We've talked a lot about this. It is one of the 9 elements of a long-term control plan, but it is not one of the elements that small communities are typically required to do, although we have pointed out that the permitting authority has the discretion to require this of small communities. But in my opinion, certainly this is a really critical item to include in your long-term control plan. You need to know your combined sewer system. You need to know how it responds to rainfall. So in other words, when it rains, how much does it have to rain for your CSOs to discharge? You need to know where your hydraulic bottlenecks are, so that you know where you need to implement your CSO controls. And basically, I think as Mohammed said before, if you don't know where you are, how do you know where you're going to go? How do you know what sort of CSO control you need to implement if you don't have a good understanding of your system? The same also applies for evaluating CSO discharges and their impacts on receiving waters. At the post-construction compliance monitoring phase, one of the things, if you'll remember, that we talked about there was doing ambient monitoring to determine whether you're meeting water quality standards. Well, certainly you want to know what pollutants your CSOs have in them so that you know what you need to monitor for when you're doing your ambient monitoring. And the last point on this is that this doesn't have to be difficult. It doesn't have to be an elaborate effort to characterize your system. In a lot of cases, people have good information on their combined sewer system, whether they have maps or they've done some sort of preliminary analyses. And my advice to this would be just to include this information in your long-term control plan, because it can be really helpful when your permitting authority is reading it to demonstrate that you really understand your system, you know where you're coming from, and you know where you need to go. So I'm not sure whether anybody had anything additional to add to this. I think we've covered this several times. The next thing that I want to talk about is choosing a CSO control approach. And over the course of reading a lot of long-term control plans, both from large communities and small communities, I was very surprised at the number of times that it wasn't clear in the long-term control plan what approach the community was using in its long-term control plan. But obviously, you need to define a goal that you can evaluate. So in other words, if you're going to try to achieve no more than 4 overflows per year, criterion 1 or the presumption approach, and that's how you're going to lay out your plan, then you should make sure that you state that in your plan so that your permitting authority and anybody that reads your long-term control plan knows that that's what you're going to be trying to do. As we've said, the CSO Control Policy provides 2 potential approaches, the presumption approach and the demonstration approach. But again, we also want to emphasize that these approaches are not guarantees. These are steps that you can take to try to achieve water quality standards, but they are not in themselves the end-all of CSO control. So permittees must still meet their water quality standards, and the long-term control plan should be flexible enough so that if you get to the point where you do your post-construction compliance monitoring and you find out that you're not meeting water quality standards, your LTCP should be flexible so that you can allow expansion or retrofit. Okay. The next thing I want to talk a little bit about is sewer separation. Sewer separation is often the solution of choice for small communities. For example, some states like Maine and Vermont strongly encourage complete separation for small communities, and even some large communities use sewer separation as part of a more comprehensive CSO control effort. They may target sewer separation for parts of downtown or other types of targeted sewer separation. There are advantages and disadvantages to sewer separation. First of all, separation can be expensive. It can also be disruptive, both to businesses in the area where sewers are being separated, and also to traffic. But one major advantage of sewer separation is that the discharge of sanitary sewage through CSOs is eliminated. So problem solved, right? Well, maybe not exactly. There are a number of implementation issues that are associated with sewer separation. First of all, when you separate sewers, this typically results in the generation of more urban stormwater being discharged into receiving waters, and this is probably untreated urban stormwater. Second of all, complete sewer separation is often hard to achieve, particularly if you don't have good knowledge of your combined sewer system. A few minutes ago, we talked about the characterization step and how this may not be required of small CSO communities. But again, unless you have a real good knowledge of how your combined system is set up, it might be hard to ensure that you've actually achieved complete separation. The last thing I want to note here is that post-construction compliance monitoring is still a requirement even when you separate your sewers. This may be something as simple as doing monitoring in your receiving water to make sure that the impact of CSOs has been eliminated. And Mohammed, did you want to say a little bit about EPA's point of view on post-construction compliance monitoring for communities that separate their sewers?
Yes. Two reasons that means you need to do the post-construction compliance monitoring for the sewer separation. First of all, like as Tim said, that complete separation of the combined system is really tough. It's almost never achievable. I have seen some very, very practical situation that where everything was done, the money was spent, especially in Region 2 right now that I'm working with this situation. Like 10, 15 years ago, the system was totally separated, but it was never totally done. We're having CSO right now. So to determine that one, whether your system is totally separated, it's always better to have some kind of monitoring whether the system is actually totally separated, yes or no. At the same time, if you have a like a water quality TMDL issue, you have a load allocation for a CSO, it's always better to find out what was the impact of a CSO on a TMDL or load allocation, or like if you have a watershed approach, like the CSO was a part of that whole watershed impacted by the pollutant, it's always to have a post-construction compliance monitoring to figure it out what was the impact. But at the same time, there is some backlash of this monitoring too. That I was a combined sewer, I separated the sewer, I'm no more a CSO community, why I need to do the requirement of the CSO? I have no answer for that one, because sometimes I say the solution is like that I have a headache, chop off my head, but chopping off my head, I may die. So we need to be careful to draw that line, especially this is the responsibility of the NPDES authority to draw the line, what needed to be done in case of sewer separation.
Right, and actually I want to talk about that a little bit more, sewer separation and its relationship to stormwater. Potentially, when you separate your sewers, you're going from one problem to another, because once you separate your storm sources or you separate your CSOs, you've got untreated stormwater going directly to the receiving water, and this can increase impacts on receiving waters. And one thing that we want to point out is that municipal separate storm sewer system, or MS4 NPDES permits, are becoming more stringent. And so you may end up having solved one problem, which is your CSO problem, but eventually having an even more difficult to resolve stormwater problem. So just something to think about if you're considering sewer separation. And I want to move on and discuss some impending issues for the CSO communities, and I'll go through this quickly. But as of July 2008, which is the last comprehensive data that we have, we're doing another compilation now, but as of last July, there were 559 communities that were implementing CSO controls. That included 451 permittees that had long-term control plans with enforceable schedules, 40 permittees that had other CSO control measures with enforceable schedules, and then 68 permittees that had separated their sewers. So there are a lot of communities that are in the implementation stage. That means that there are a lot of communities that are starting to look into the different types of CSO control technologies that they might implement. And also there are some permittees that are actually past that and that are into their post-construction compliance monitoring phase. So just be aware that there may be other resources out there. There are probably other communities that are starting to face the same implementation issues that you are, and forums like this are a good opportunity to share that type of information. Okay. Now I want to talk, I'm going to go into the Long-Term Control Plan EZ, LTCP-EZ, and the green LTCP-EZ tool. And I want to start off by talking a little bit more about small communities and how they're implementing long-term control plans. So just a little background to start us off. We've been talking a lot about requirements for small community long-term control plans, but the fact is that a lot of communities, a lot of small communities, have not yet started their long-term control plan efforts. There are a number of different reasons for that, including budget problems, lack of staff resources, other priorities for staff attention, etc., things that I'm sure that we can all relate to. And so in order to deal with that, EPA has developed the LTCP-EZ tool as one way that communities can do their long-term control plans. So what is LTCP-EZ? LTCP-EZ is a planning tool that helps communities do their CSO planning and prepare a long-term control plan that addresses the expectations of the regulatory authorities. And if you complete the LTCP-EZ forms, you can actually submit these forms as your long-term control plan because they have all the information that the permit writer should be looking for. What does the LTCP-EZ consist of? Well, it looks like the 1040 tax form. And while that might not be something that everybody's in love with, it is something that people are familiar with, and that's the point. The LTCP-EZ is laid out in a logical, step-by-step manner, just like I'm sure we all agree that the tax forms are. In the case of LTCP-EZ, what you do is you fill in a main form with lots of basic information, and then you attach schedules with extra information that may or may not be applicable to your specific situation. LTCP-EZ has line-by-line instructions for how to fill it out, and then you attach any additional documentation that's required. You submit the package to your permit writer. It undergoes state review, and hopefully you come out with an approved long-term control plan. So here is LTCP-EZ in, or the process in a graphical format. You can see on the left that Form LTCP-EZ incorporates elements from the CSO Control Policy, and also it can be, you want to make sure that you include any state permit requirements as you're filling out the form. And on the right are the schedules. So the LTCP-EZ format also includes information for you to document your implementation of the 9 minimum controls, a request for a map of your combined sewer system, space where you can document your public participation, and then the last 3 schedules are CSO volume, where you calculate how much volume you need to control in order to comply with the CSO control policy. Schedule 5, you look at how you're going to implement your controls. And then Section 6 is the CSO affordability analysis, which Jim has summarized previously. The LTCP-EZ process, the first thing you want to do is you want to review your regulatory requirements, for example, your NPDES permit, to determine what requirements you have to do a long-term control plan. Then you want to review the LTCP-EZ template and its instructions, make sure you understand everything. And after you do that, you want to make sure that you coordinate with your regulatory agency on using LTCP-EZ. It may not be appropriate for everyone, so that's a really important step, is to talk to your regulators and make sure that LTCP-EZ is appropriate for you to use. Then you want to get all the information that LTCP-EZ requires, fill out form LTCP-EZ and any other schedules that you might need. And then, as we said, you can submit the filled out form as your draft long-term control plan. Here is another graphical depiction of this process. You can see that you review your regulatory requirements, fill in your template, and then you've got a draft LTCP, and the whole time you're coordinating with the regulatory authority. Then you submit that LTCP-EZ template, and you negotiate that with your permitting authority, and you come out with an approved LTCP. Couple reminders. First of all, the LTCP-EZ template is not intended to replace any statutory or regulatory requirements applicable to CSOs. This is just a tool, and it doesn't get you out of any CSO requirements. Second of all, the template's good for small communities with simple combined sewer systems. However, as we emphasized, you want to talk to your permit writer to make sure that this is an appropriate tool for you to use. Third, EPA uses the presumption approach in the LTCP-EZ template because it's a simple method. However, this does not mean that EPA is prescribing use of the presumption approach over the demonstration approach. And now we want to go through each of the individual forms. First of all, purpose of form LTCP-EZ. This summarizes the most important information for the permittee, for example, the name of the permittee, the NPDES permit number, etc. It allows the permittee to document their understanding of their combined sewer system, and it is the main organizing form that you attach all of your schedule to so that it can serve the draft LTCP. And here we have a picture of form LTCP-EZ. It's probably a little bit hard to read, but here is where you input all of your general information, gives you some space to describe the water quality in any sensitive areas that you have, to discuss your implementation of your non-minimum controls. That's considered Schedule 1, where you attach information on your non-minimum controls. Schedule 2 is a map of the CSO system, including the outfalls. And then Schedule 3 is an attachment describing how you did your public participation program. Schedule 4 is CSO volume. And as I stated, Schedule 4 rests upon the presumption approach and the criteria to control overflows to no more than an average of 4 overflows per year. Schedule 4 uses a simple model that's based on the rational method for generating runoff and a design storm approach. And basically what Schedule 4 does is it estimates the CSO volume that needs to be controlled. And as we stated before, you can use other approaches if you want to use the 85% capture approach or criterion 2 of the presumption approach or the demonstration approach or any other type of approach. You can use those, and you can still use LTCP-EZ, but you can't use that in Schedule 4. You're going to have to do that analysis on a separate, as a separate item and attach that. Schedule 5 is once you've determined how much volume you need to control through Schedule 4, Schedule 5 is an iterative approach to looking at some individual types of controls and doing some scenarios to determine how much control you could implement with each one of these different types of CSO controls until you get down to meeting the volume requirements that you've calculated in Schedule 4. Schedule 5 includes conveyance and treatment at the wastewater treatment plant, inflow reduction for residential properties, sewer separation, and offline storage. Schedule 6 is the CSO affordability analysis, and this is the same financial capability analysis that Jim went over earlier, except it's in an LTCP-EZ format. And as Jim noted, this is primarily useful as a tool for negotiating your schedule, but it does not eliminate requirements to control CSOs. And finally, I want to talk a little bit about green LTCP. this basically adds green practices to the LTCP-EZ template. There's been a lot of interest recently in doing green infrastructure, and EPA recognized that and decided to develop the LTCP-EZ green template. Basically what this does is it uses green practice to compute a reduction in runoff that reduces the CSO volume that you've calculated in Schedule 4. And then in Schedule 5, you can evaluate some specific types of green practices to achieve that runoff reduction. However, we would caution that using green LTCP-EZ, you want to do this in close coordination with your permit writers, because there's still a lot of debate about whether about the most appropriate methods for evaluating green infrastructure. So make sure before you do anything like this that you coordinate with your permit writers. We expect to have a draft of green LTCP-EZ in July 2009, and then we're planning on doing another webcast that will introduce green LTCP-EZ in more detail in September 2009. And that is the end of my presentation.
Jim and Adrian, I can see that you have a lot of questions to answer, but I think we're running out of time. But I have some questions that here related to a couple of updates, like the green LTCP-EZ and post-construction compliance monitoring. I have some questions that what is the status. Just let everybody know post-construction compliance monitoring final draft is ready, and it will be going for the review, EPA review internally and the region within next 2 weeks. And I'm expecting to for the state within maybe like 3 weeks or 4 weeks. Then I'm expecting to finish up the final of this post-construction compliance monitoring document by September 2009. And green LTCP-EZ update that I'm expecting to do a pilot ASAP when the document is done within July, August of 2009. So, Jim, anything from you, or Adriana, we want to finish it up?
Well, I want to go ahead and cover a couple items, but thanks, everybody. Today's seminar will be archived, so you'll be able to access it after today's live presentation. The archived webcast will be posted within a few weeks, so you can revisit the EPA CSO website at the www.epa.gov/NPDES/CSO site. And we've also posted the speaker's contact info there. And if you'd like to contact any of us after that today, that's fine. You'll also find an updated comprehensive resources list in a few weeks. We'll make sure that's updated because we were told that the Region 5 financial affordability document didn't seem to work on that link, so we'll make sure that gets straightened out. So the webcast evaluation survey should be appearing on your screen. There it is. Please consider completing this survey now and let us know your thoughts. We appreciate your feedback as we work to improve our webcasts. If you do not see the evaluation survey on your screen, please turn off your pop-up blocker. And then I'd like to announce that we had approximately 275 attendees at today's webcast, which is great. The certificate of participation is available. It's available by clicking. There's a certificate button on the screen. Remember, if you have multiple attendees, you can click the link to download that certificate to your computer, and then you can type in the attendee's name in the field, in the name field, and then print the certificate. So at this time, I think we'll have to conclude today's webcast. Thanks, Mohammed and Tim, for presenting today. And thank you to everyone who joined us.
Thanks, Jim. Thanks, team. Thanks, everybody.